There is a crisis in the universe, and the fate of the entire cosmos depends on it. Since 1929, we have known that the universe is expanding. That year, Edwin Hubble first proved that galaxies are gradually moving away from each other over time. This expansion forms the foundation of our entire theory of cosmic evolution, from the Big Bang to the formation of the universe itself. The most important factor here is the rate of this expansion, a value known as the Hubble Constant. For a long time, we believed this value was quite precise. But now, astronomers are no longer so sure. Are we on the brink of a cosmic revolution, or could we be wrong? I'm Carl. Welcome to my channel. Let's explore how Hubble's greatest discovery has turned into one of today's biggest questions. For most of human history, the universe was thought to be just the atmosphere, or at least that's what we believed. Some ancient civilizations imagined the Earth as flat and covered by a dome filled with stars. The sun and moon rose and set, and the constellations rotated across the sky. By the 2nd century, astronomers such as Claudius Ptolemy had designed a model of a geocentric universe where the Earth was at the center. The sun, moon, planets, and stars all revolved around it. This model was accepted for over 1,000 years, until the 1500s, when Nicholas Copernicus introduced the heliocentric model. According to this model, the Earth was just one of many planets orbiting the Sun. This was a truly revolutionary idea. By the 18th century, William Herschel mapped parts of the stars in the Milky Way and showed that it was a massive disc-shaped system. But even then, astronomers were still debating a key question. Was the Milky Way the entire universe? Or was it just an island galaxy in a much larger cosmos? This question was finally answered in 1923 by Edwin Hubble. Using the 100-inch Hooker telescope at the Mount Wilson Observatory in California, the largest telescope of its time, he observed Andromeda. And there, he was able to resolve individual stars. Among these stars, he identified a Cepheid variable star. Thanks to Henrietta Leavitt's method, these stars could be used to measure distances in the universe. Hubble calculated that Andromeda was approximately 900,000 light-years away from Earth, an astonishing distance. This distance proved that it could not be part of the Milky Way. In other words, there were other galaxies. Suddenly, our view of the universe changed forever. But Hubble did not stop there. Using the same method, he identified 23 more galaxies and measured some as far as 20 million light-years away. He ultimately concluded that the universe contained far more than just our galaxy. At this point, the work of another astronomer enters the story, Vesto Slipher. Between 1912 and 1925, he observed more than 40 galaxies. When studying the light coming from these galaxies, it was discovered that if an object is moving away from us, its light shifts toward the red end of the spectrum. This is known as redshift. Slipher found that nearly all galaxies appeared to be moving away from us. However, at the time, he could not measure their distances, so he could not fully interpret this observation. In 1927, Georges Lemaitre proposed a theory suggesting that the universe was expanding, but he lacked sufficient evidence. That is, until Hubble re-entered the picture. Hubble confirmed that galaxies were moving away, but he also discovered something no one had noticed before. The farther away a galaxy was, the faster it was receding. And this was true in every direction. This became the strongest evidence that the universe is expanding. In 1929, he published this discovery. It became one of the foundational pillars of the Big Bang theory. Hubble also calculated the rate of the universe's expansion. This value later became known as the Hubble Constant. His initial measurement was not perfectly accurate, but it was refined over time. Today, this value is fundamental for determining the age and size of the universe, among many other cosmological calculations. However, there is a problem. There are two different ways to measure the Hubble constant, and they do not agree. The first method uses observations of redshift in distant galaxies. This gives the current rate of expansion of the universe. The second method looks back to the very early universe. It relies on the cosmic microwave background radiation. This is essentially a snapshot of the universe about 380,000 years after the Big Bang. But here is where the issue begins. These two methods produce different results. One gives approximately 73 kilometers per second per megaparsec, while the other gives approximately 67 kilometers per second per megaparsec. This discrepancy is known as the Hubble Tension, and this small difference represents a very big problem. Because if one of these values is wrong, then our entire cosmological model could be wrong. Perhaps the universe is younger than we think. Perhaps we are missing something about dark energy. Some scientists even suggest that we may need to rethink the fundamental laws of physics, but perhaps the solution is simpler. A new theory suggests that the universe may be rotating extremely slowly. If this is true, it could explain both early universe measurements and present-day observations at the same time. This idea is still under investigation. But if it turns out to be correct, our understanding of the universe could change once again. Because maybe, not only the Earth, not only the solar system, not only our galaxy, but the entire universe could be rotating. Thanks so much for watching my video. I really appreciate you taking the time to be here. If you enjoyed it, don't forget to leave a like and consider subscribing. It really helps the channel grow and keeps me motivated to create more content like this. Also, if you want to be notified right away whenever I upload a new video, make sure to turn on the notification bell so you don't miss anything. Thanks again for your support, and I'll see you in the next video.